So same FRQ again. New question. Approximate the value of this integral using a left, that's key, Riemann sum, 5 subintervals indicated by the data in the table. Stop. Always stop and do what they ask you to do on an FRQ. Don't keep reading. So I'm supposed to find this integral, so I have to write down the integral. In many cases, if you don't write down the integral, you won't get the point. Make sure you are grading yourself very strictly. You're not going to help anything by saying, oh, it's close enough. You've got to have exactly what they have. So you have this integral, because that's what they asked you to do. Don't forget the dt. Left Riemann sum means I'm supposed to start at time 0, go all the way to time 90, and I divide this into subintervals. So the first subinterval is from time 0 to time 30. I pick the value that is most left in that subinterval. That value is 20. So that's why I wrote 20 here, multiplied by the dt, or the difference in time, or the change in time for that subinterval. The time changes by 30 minutes, so I multiply those two together. Plus, go to the second subinterval, the change in time is now 10, the value that is most left is 30. So here's the 30, here's the change in time. The AP test writers wrote them backwards. I prefer the other direction, but it doesn't really matter because you're multiplying. So you continue to do that for each subinterval. You don't have to compute the 3700. As long as you have this red box written out perfectly, you'll get the 1 point for the value of the left Riemann sum. Next question. Is this numerical approximation less than the actual value of the integral? Explain your reasoning. On the back of the golden notes, there's a box that says, I believe the symbols are different, but same idea. In this case, we are integrating r. So we're trying to figure out if our integral approximation of r is more or less than the actual integral would be. So I'll say that one more time. We're trying to figure out if our integral approximation, if our Riemann approximation of the integral of r is more or less than the actual integral would have been. The easiest way to see that is with the graph. So I'm going to page back here. We went from time 0 to time 30. We picked the value of r on the left, so we picked 20. We multiplied 20 by 30. The difference in time, the dt, or the change in time for the first subinterval. We multiply those two together, we are computing the area of a rectangle that would fit like so. Therefore, our Riemann approximation is going to be an underestimate because we would have preferred to find all of this area. That would have been the ideal case, to find all of this area. We didn't, we found less. So as indicated by this little reminder on the back of the golden notes, because r of t is going up, right here, r of t is going up. That's why they said r of t was strictly increasing. Because r of t is going up, we know that the left Riemann sum is going to be an under approximation. This green box is one way to say it. This green box over here is another correct way of answering the question. If you have either of those green boxes, you get the second point. So 2 points total for part 3C.